Hey, welcome to this video on dividing polynomial by a binomial. I should say rather dividing a binomial by a polynomial. This is very, very important because this leads towards factoring, and in the future you will be working with many questions in algebra where you have to factor and simplify an expression. So let's begin very slowly with the following example. You see that the area of a rectangle is provided, and that area is 8 units, or meters squared in particular. So area, and any area is always a product length times width. But in this problem, they say find the width. So width is unknown and the length is provided. So to solve for the width, please note we have to divide area by length. So if you rearrange the formula and you want to express W in terms of A and L, so that makes sense to say that the width W is equal to the following ratio, A divided by L. And this is what is taking place right here. So the width is equal to 2 meters. Right? If you want to verify 2 meters, let's say on this side, and 4 meters on that side, so the area must be 8 because you multiply 2 times 4. Now, we will show you an example that involves variables. So in this example, we need to divide a binomial 2x squared by plus 6x divided by 2x. So this is the challenge. From a rectangle with this area shown right here on the left side of the screen. So this is 2x squared tiles and 6x tiles. So we have to divide this by 2x in order to find the missing pieces on this side. Right, so we have to figure out what tile possibly could fit on this side. So when you multiply by 2x, you must get 2x squared plus 6x. So let's grab those tiles provided on the right side of the screen and see what would make sense. So 1x tile and then 3 unit tiles. So this is the proposition. When you divide this polynomial, binomial in particular, 2x squared plus 6x by 2x, the result is x plus 3. So this is the proposition. 2x squared plus 6x, when divided by 2x, the answer is x plus 3. And now the challenge is to really show algebraically that this is the case. So let's move to the next page. So 2x squared plus 6x shown on the top of the screen. And before we proceed with the actual division, we will have to find sort of prime factors or factors for each term. 2x squared can be split as 2 times x, and 6x can be split into a product 2 times 3 times x. So the greatest common factor is 2x. And why is that? Because please note, if you have 2x and x term, and then you have 2 times 3 times x, the common factor for both is 2 here, 2 there, 1x and 1x. So this is it. This is the greatest common factor. So moving along with the division process. 2 x now is taken outside. So from the first factor, I have 1x left. So if I take out 2x, I have 1x left. So this is y. And then plus, because this is a positive term, 2x squared and positive 6x. If I take out from 6x, take out 1, 2, and 1x, what I have left is just 3. So this is why you go with plus 3 inside the brackets. And this is divided by 2x. So now please note, in the process of dividing, you can simplify. So 2 can be divided by 2, and you have 1 and 1. Similarly, you can divide x by x, and you have 1 and 1. So in the end, we have x plus 3. And this is what we saw on the diagram on the previous page when Algebra Tiles model was used. So remember, to divide a binomial by a monomial, all we have to do is to be able to find a common factor. Once the common factor is established, you proceed with the division step and you simplify to get the answer. So the rectangular shape, just to summarize, with the area of 2x squared plus 6x can be factored into the following: 2x and x plus 3 on this side. Because when you multiply together length times width, you must get the formula for the area. I hope this video helped you to understand how to divide binomial by a monomial, and the algebra tile models also was useful for you to understand the process of dividing. And I hope that the algebra expression using the paper and pencil method also allows you to learn the proper way of dividing terms in algebra. Thank you for watching it, and I see you next time.